In this problem, we have two blocks being pulled across a table. First, we're going to draw the free body diagrams when the table is frictionless, and then we're going to do it when there's friction and the blocks are moving at constant speed. So in the first part, we've got block A and block B. What's touching block A? Block B is touching block A, right? That interface there, the two surfaces. Surfaces can interact with a normal force. That's the force on A from B. And through a friction force. And what direction is the friction force going to be on block A? Block A is moving to the right. And what's causing it to move to the right? The static friction force between those two blocks. That's the only thing touching block A. Of course, gravity reaches in, so we have the weight of A here. On block B, what's touching block B? Well, the rope is, so there's a tension. And the table is touching block B. A table can interact through a normal force and through a friction force, but there's no friction in this case. The table is frictionless, so we only have a normal force. The other thing that's touching block B is block A. Block A can interact through a normal force and through friction. And something can reach in from a distance, and that's the weight of B. Gravity can reach in. So those are our free body diagrams. Let's take a second and think about Newton's third law pairs. We have a normal force acting on A from B, and a normal force acting on B from A. Those are a Newton's third law pair. We also have a friction force acting on A and a friction force acting on B. Those result from the same interaction. So we have two Newton's third law pairs. Now, if we add friction such that the friction force is equal to the tension, then we get constant speed, constant velocity, or zero acceleration. And so we're going to draw the free body diagrams in this case. So for A, we're going to have a normal force on A from B. It's touching that surface. But an interesting thing happens here. What happens to the friction force? It has to be zero. If these blocks are moving without any acceleration, there has to be zero net force in that direction. A is moving to the right because of its own inertia. It doesn't take any force to keep it moving at constant speed. So that's our free body diagram for A. B has the rope. It has a normal force from the table. It has a friction force. That's a kinetic friction force on B from the table. A is touching it with a normal force, but no friction force. And then we have the weight of B. Newton's third law pairs, the normal force on A from B and the normal force on B from A, and that's it.